Okay, so I'm gonna talk about how would I approach those questions. Make sure you go through all the things, write down the things that you're missing. Um, so let's look at a question. Can somebody tell me the questions? Oh, there's a question. No man. Um, copy, paste. Okay. I'm gonna go to here and I'm gonna open up here. So first of all, we're gonna find all the information. And I forgot to mention that before you find all the information, it's probably better to factor everything because sometimes you can find a hole and will be like, for example, second equation doesn't have a anything. So I always factor. So write it down that always factor first. If you can, you're gonna always factor first. And I'm gonna factor the top. So it'll be 2 times x plus 3, x minus 3, over x plus 2 times x minus 2. Now this is just equation that hopefully that we see something we can cancel. If something can cancel, we see the whole, we see the x value of a whole, we can plug it back in to find the y value if we can simplify this. But it turns out we cannot simplify this, nothing we can do. Okay, great. We're just gonna move on. So that's fine. The symmetries. Now for symmetry here, I will go with here. So I can go with either equation, but I will probably go with the first one here because the first one is easier to tell. So let's just say symmetry, I'm gonna plug in negative x. So it'll be 2 times negative x squared minus 9 over negative x squared minus 4. And that's gonna be 2 times x squared minus 9 over x squared minus 4. Is that even or odd?
Even.
Okay, so most of you guys know how to find even function now, right? Now, what is even? Even has symmetry to y-axis. Now, just to remind you on the side, what happened if it's odd? Symmetry to origin. What do you mean by symmetry to origin, though? Later on, we might give you a question that has symmetry to origin. But symmetry to origin is basically you're gonna have the you're gonna have an opposite coordinates. So if one on the fourth quadrant and the one on third quadrant, the thing is gonna be exactly copied at the first quadrant. So they are quadrant opposites. I don't know if that makes sense. Like XQ graph. XQ graphs like this, right? Waterfall. Those are opposite to the origin. Symmetry to origin. So they are XQ graph like that. Actually, y equal to x graph is also symmetry to origin because they have on first quadrant and third quadrant. So they are quadrant, they are opposite to each other. Does that make sense? Okay. So let me give you some example of origin. So that's going to be like something like this, something like this, because see this quadrant and this quadrant, they're opposite to each other. If a symmetry to y-axis will be first and second, but they are symmetry to first and third, or second and fourth. Is that okay? Okay. So B, what do we find? Y-intercept. How do I find y-intercept? Plug in 0 for x. Now this is a very important tool for any exam. SAT, AP exam, very important tool. Plug in the opposite. Okay. So opposite equal to 0. So x equal to 0. So I'm going to plug in 2, 0 squared minus 9 over 0 squared minus 4. So that's going to be what? 18 over 4, 9 half. So it'll be 0 and 9 half. Y-intercept. X-intercept. What is X-intercept? Well, that means f of x, y or f of x equal to 0 because y is f of x. So 0 is equal to 2 times x squared minus 9 over x squared minus 4. Now I can times both sides by x squared minus 4, and that's going to be x squared minus 9 equal to 0, x plus 3, x minus 3 equal to 0. So x equal to 3, x equal to negative 3. So that's going to be, wait, hold on a second. 3, 0, and 0, negative 3, 0. So far, we okay? Mm-hmm. It doesn't matter if I divide it by 2 on both sides. It's gone. Yeah, because imagine that I have 2 here, right? I can divide by both sides by 2, right? So 0 divided by 2 is still 0. And it's just going to be x squared. So you're going to have a 2 here. That doesn't give you extra zeros. Does that make sense? D. Are those people fell asleep? Okay. Next question. What is D? Vertical asymptote, which is denominator equals 0. The leftover denominator. Since there's nothing cancel out, it's going to be x squared minus 4 equal to 0, x squared equal to 4. You can do it this way too. X equal to plus minus 2. Just don't forget plus minus. Some people do it this way. That's fine. X equal to negative 2, x equal to 2. This is probably more accurate way because you're not going to forget plus minus. A lot of people square both sides, they forgot the negative side, which is that's very scary. So you have to pay attention to those small different parts. We're going to find a behavior at a vertical asymptote. Now, this is quite confusing for some of you guys. Now, obviously, on a number line, you have a negative 2 and 2, there was an asymptote. So there were some points beforehand, there's some points afterhand, there's some point and some point here. I say use 0.1 away because if you plug in 0.1 away, you know what that behave. Are they going to go into negative infinity or positive infinity? Vertical asymptote can only have 2 choices. They can only go up or go down. If you find a value that's really close to it, is negative, that means they're going to go down. 0.1 is very good. If you say, I'm going to use 2 away, let's say I plug in 4, sometimes they can be positive. So you want to get as close as I can to get to that vertical asymptote, and you're going to test it. You don't need an interest about values, you're interested about the sign. So that's the thing. So what would be a good value to plug in at this moment before 2? Negative 2.1. Good. So this is the point I'm going to test. And then what's this side? Negative 1.9. Good. If you look at a number line, that's going to be really easy. 1.9 and 2.1. Sorry. I'm going to plug in a factor form because I think that form is easier for me to judge the sign. So let's just plug in negative 2.1. So negative 2.1 at this particular case. So it'll be 2 times negative 2.1 plus 3 and negative 2.1 minus 3 over 2.1 plus 2 and then negative 2.1 minus 2. So I don't really care about, again, I don't really care about the number. I care about a sign. So it'll be 2 times positive, right? Is that okay? What is this next sign? Negative. What's the sign on the bottom? Negative, because negative 2.1 plus 2. And then negative, right? How many negative signs are there? So what do you think the end sign is going to be? Negative infinity. So limits as x approach 2, or negative 2 from the left. Negative 2 from the left of f of x is going to negative infinity. Does that make sense? Let me know if it doesn't make sense, because half of the class should have question about this. Yes. Bennett? You understand or you don't understand? Don't? Bennett?
No, I don't understand.
You don't understand? Which part you don't understand?
How do you know it's coming from the left?
How do I know coming from left? Because I pick a value at negative 2.1. It's left of negative 2. If it's left of negative 2, I'm going to plug into the function. I don't even have to write it out. I can actually see it as positive or negative because I can do that calculation really easy. Negative 2.1 plus 3 is positive. 9.2.1 minus 3 is negative. Negative 2.1 plus 2 is negative, and this is negative. Total those three negative signs, it will end up to be negative. If it's even among the negative sign, it's going to go to positive. Yes, Brendan?
When would you use positive?
I'm going to get there. So limits. So let's say if I use 1.9, right? So can I eyeball it? If I use 1.9, it's going to be what? Negative 1.9 is going to be what? Positive. Negative 1.9 is what? Plug in here. Negative. Negative 1.9 is what? Positive. Negative. So how many negative signs are there? 2. So it's what? Positive. So therefore, limits as x approach to negative 2 from the positive side is going to be positive infinity.
Negative 2 or 2?
Negative 2. Negative 2 from the positive side.
And are you always going to add or subtract to 0.1, or is it
just 0.1 because that's the most accurate, because you're going to see, are they for sure going, if you get so close to asymptote, they either be positive value or negative value. So if it's positive value, it's going to go to infinity. If negative value, it's going to go to negative infinity. Are we okay here? Okay, yes.
Oh, could you explain why is x approaches negative 2?
Because of the vertical asymptote. Asymptote is the something I'm interested. How do they behave right next to asymptote? Do we forget to find horizontal asymptote? Okay, let's go back and find horizontal asymptote. I'm so sorry. So horizontal asymptote is this. So horizontal asymptote is going to be what? 2. Okay. So horizontal asymptote. So horizontal asymptote, because they are same degree, so there's going to be 2. So those are the things that we need. We don't have no holes, and this actually just good enough to graph, believe it or not. But I'm going to go ahead and do more. So limits x approach to 2 from the left side. What do you think is going to be? Let's eyeball see what happened. 1.9 is what? Positive. 1.9 negative. 1.9 and then 1.9 negative. So it's still 2 from the left side is positive, right? And limits x approach 2 from the positive side. More likely, I think it's all gonna be positive, I believe. Let me check. Positive. Wait, negative. Positive is negative, right? Okay, so let's go check out what happened. First of all, I will graph out asymptote. I always go with vertical. They are the most important. They are the badass of the badass. Nobody can touch them. Horizontal asymptote is like, yeah. Sometimes you can touch them. But this is the horizontal asymptote. Oh, vertical asymptote. 9 over 2 is 9 over 2. So roughly 4.5. So 4.5 is right here. So just by doing this, you can pretty much, huh? Oh, that's a y-intercept. So what is a 2? Sorry. 2 is gonna be right here. Got it? So now let's look at it. Y-intercept is where? 4.5, so it's right here. Okay, so also x-intercept, do they have x-intercept? -3 and +3. We already know where the graph is going to be, just by those 3 points. We already could know the graph's going to be in those sectors, but that's okay. We're gonna see how they behave. Now for this side, it's gonna go, if I have a point right here, right? I'm gonna use this kind of marker here. If I have a point right here, if I'm going to the left side, it has to go plateau into the asymptote. You're not gonna go past the asymptote because that's the end behavior. So you're not gonna go past the asymptote. It's gonna go toward the asymptote. Is that okay? So this part is gonna go here. And this part, again, is going to go toward asymptote because it says, hey, it's going to negative infinity. It's not going to go up because they say from the left side is negative infinity. How many people are confused? Raise your hand if you're confused. Yes. What? Yeah, but it's not necessary. Only if they told me. We're gonna go through one, might be like that. Okay, so now on this side of asymptote, on the -2 from the right, so there's 2 choices, right? They're gonna go this way or go in this way. What do they tell us? Huh? They're going to positive, so it has to be going positive like this. And guess what? You already can graph the rest of them without knowing the rest of the information. You can just look at the symmetries. Symmetry is gonna give you this side. I'm gonna draw a symmetry and symmetry, and you already finish your graph. Is it hard? Probably just all the information combined together is hard, but yes.
How do you know there's no holes?
Good question. Do you see any factor that you can cancel? Do you see, does this, oops, my bad. Does anything cancel out here?
Wouldn't 2 and -2 cancel out?
This? Oh, hell no. You break math
no,
there.
never mind. No.
You break math there.
No, like I meant like if you plug in 2 and -2.
I don't know what you mean by that. Plug in 2 and -2? There was no factor that can cancel out. So let's go through the next question. So there's a reason why I told you to factor first. If you factor this, it's gonna be x minus 4 and what? X plus 2. And then x minus 4, guess what? Boom, boom. There is a hole because there was something cancel. And there is a new equation that here that you generate is x plus 2, which is very easy to graph. There's no vertical asymptote anymore because it's already canceled. It's just a simple hole with a straight line. So you don't need to find all this information. There is no symmetry. There's the x-intercept. There's y-intercept. There's no vertical asymptote. There's no horizontal asymptote. There's no removal discontinuity in this case. So x-intercept, well, first of all, I'm just going to graph x plus 2. X plus 2 is too easy to graph, so it's going to be like this, right? We already, because we're graphing this, we're not graphing this. But where's the hole? What can you tell me where the hole is? Huh? -2, good. X plus 2. Oh no, not -2. Where's the hole? Yes, Bennett. 4. Good. X minus 4 equal to 0. You set the cancel factor equal to 0. And you say x equal to 4. But where's the y coordinates? 6, because you plug in 4 into here. Is that okay? Because you always want to find y value. You already find the x value. All you got to do to find y value, just plug in the equation. Which equation? The new equation. Because you plug in the old equation, you're going to get 0 over 0. Which is, you don't know what that is. Which is, we also know as. So right now, I'm going to go down here. I'm going to just graph this because that's why I asked you to says always factor first. Well, I forgot to ask you that in the class yesterday. But 4 is going to be like this. And there we go. There's no horizontal, there's no nothing. Got it? All right, so I want you to grab this one. Let me see. Try to don't look at each other. Try to grab all the way to the end. And I'm going to the second one before go after the first one. Well, sometimes you have no symmetry as well. But this one, check with each other. What do you think the symmetry is? If it's exactly the same as before, then it's gonna be symmetry to y-axis. If it's exactly opposite than before, is what? Symmetry to origin. So what's the symmetry of? How many people say it's neither? How many say even? So nobody's even, which is good. So we have two choices left. Robert, are you willing to change? No? You're wrong. You should always change. I don't know why, but I saw this clip from, I don't know, this movie called 21. Have you seen this movie called 21? Like basically he's an MIT student and he was in a he like there was a math question. This MIT professor said there's a 3-door open, and each door, like one of the door has a $1 million, and the game show host is gonna says you can choose those 3 doors, and he said I choose door A, and the game show host says, well, I'm gonna open the door C, and then the door C is nothing. And then he says, well, you choose A, do you want to change? And the kid says, yes, I'm going to change. And he asks him, why? And he says, because math. That just increased my odds for 33.3% if I change. If I don't change, I lost. But he's like, how do you know? Because I might be reverse psychology. Maybe that is the, that's not $1,000,000. And he said, well, that's a very interesting clip. I still don't understand the math, but he says you increase 33.3%. So if I ask you to change, you might want to change next time. I don't know if you will see this another game show of like open the box and then there's money inside. I think. But yeah, you can watch a clip. It's interesting. It's not neither. It's actually odd. It's actually symmetry to origin. Yes.
Isn't it statistic, if there's 3 doors, you choose one, then they open a different door, and the different door is wrong. Then you can change your, if you change your answer, it's now 50-50. No, it's 60 point, it's 66 from a 33 or something.
Yeah, it's something like that. And I don't know why though. It doesn't make sense to me, but it's a one of stats problems, which I don't do stats. I do math. So it's symmetry to origin. You finished graphing? That's it?
Right, I had it wrong.
Negative x inside of parentheses. Negative x. So once you know, and your vertical asymptote is not. Yeah. The reason being because you do x squared minus equal to 0 means 9 over x squared both sides.
Mine's 9. Negative enough then it's left. That'd be negative. Sorry, I knew for a second coming down. Here, so it'd be like here and here.
No, then you gotta test. You gotta test the behavior. Draw the asymptote first. Usually that give you very good guidance and a lot of points. It's for all the asymptotes and all the x inside and y inside. Because that can give you a generalized of the graph.
If you're coming from 2.9, 2.9, there's nothing. Yeah.
Okay,
So it's going down.
X and Y
If you plugged in 2.9.
Your horizontal asymptote is wrong, I think. Yeah, but then your horizontal asymptote is not right. It was second question, Austin. Coffee is not strong enough. A hot chocolate.
It's so bad.
So yeah, is 2x cubed or squared?
2x cubed. The second one?
Yeah.
Safa, I think your graph is wrong.
Wrong.
Yeah. So I'm gonna start by factor this and test for the symmetry. So I'm gonna plug in negative x. Now, so some of you guys like plug in negative x is wrong. I saw Emerson did this. If you plug in negative x, that means x. I'm gonna plug in negative x here, and I'm gonna plug in negative x inside of x and then square afterwards. Do you see what I'm saying? And this one's gonna be negative x over x squared minus 9, which is exactly opposite negative over original function. So this is called R functions, and they have a symmetry of origin. X-intercept means y equal to 0. So x-intercept, y equal to 0. So 0 equal to x over x squared minus 9. And then that's going to be x, just numerator equal to 0. Is that okay? So you should get 0, 0. C, y-intercept is 0, 0, because I'm going to plug in f of 0. That's going to be 0, 0 squared minus 9. That's still 0, 0. They both are the same. Vertical asymptote. Horizontal asymptote, vertical asymptote. Okay, so vertical asymptote is going to be x equal to negative 3 and x equal to 3. Horizontal asymptote is what? Y equal to 0. So just by this, we can graph most of the information, at least all the x-intercept, y-intercept, horizontal asymptote, vertical asymptote. All this information, I'm going to graph. I'm going to start sketching it because I'm going to find out how they behave in a second. So at this, I'm sorry, this is wrong. This is negative 3. And this is 3. And there is a asymptote this way. And there is a 0. Now, you're like, no, they cross the horizontal asymptote. I don't really care in the middle region. I only care about what happened later, which is all the way to x axis to the end and all the way to the other side. Remember, horizontal asymptote in the middle region you can cross. In the end region, it's not gonna cross. So that part doesn't really matter. Got it? Okay. So what's the point I'm gonna try? I'm gonna try negative what? 3.1, right? What else? Negative 2.9. What else? 2.9 and then what? 3.1. So I'm gonna plug in that. I'm gonna plug in very original equation. I'm gonna plug in that. So that is equal to positive on the top. Do you see that? Negative 3.1 plug in here. What am I gonna get? Plug in x plus 3. Negative 3.1 plug in x plus 3 is what? Think about it. If you have x over x plus 3, x minus 3. What happens if we plug in negative 3.1 here? Negative. You gotta tell me that. And how about the other one? No, negative. Negative to 3.1 subtract 3, it's gonna be negative. Yes, Brandon.
Wait, how's the top positive?
Oh, top. Oh, yeah, top is negative. My bad. Yeah. So what happened at the end is what?
Negative.
Negative infinity. So on this side, it's going toward here, negative infinity. Does that make sense? Is this okay? This part is going to go to the horizontal asymptote. Am I losing you? Okay, 2.9. Is 2.9 on the top negative or positive? Negative. How about the bottom?
Positive and negative.
Positive and negative. So that's going to be positive. So it's going to be like this, right? Now remember, you already have a symmetry. There's symmetry to origin. I can graph this side, it's going to be like this. And this side is going to be like this. You can check whether it's true. If I plug in 2.9, what will happen? Positive, positive, negative, which is going to negative. That's right. And 3.1, positive, positive, positive. Yep, perfectly.
But how can the line in the middle, how can that appear if there's only 2 degrees?
Say that again.
Why is there that third line in the middle if the exponent's only 2? Doesn't that tell you that there's only going to be 2?
To what? Oh, this?
Yeah.
That 2 is what? 2 is they are not making the sense. Rational function in the bottom, it doesn't provide, that tells you there's 2 x-intercept, but it's not, it doesn't apply if something is on the bottom, the degree is on the bottom. So if I were to say all the M behavior was limit x approach to 3 from the left of f of x is equal to negative infinity, limit x approach to 3 from the positive, or negative 3, sorry. Negative 3 from the positive is going to be positive infinity, limits x approach negative 3, or positive 3, sorry. 3 from the positive side, that is going to be, no, 3 from the negative side first. It's going to be negative infinity. Limit x approach 3 from the positive side is going to be positive infinity. So this is what I end up to be because I check all the signs. And that's my graph. Very simple. It's not as hard as it looks. But you guys gotta go in and try to do it, because if you don't try to do it, you don't know what happened. I'm gonna take this function. I don't have enough time, but I'm gonna try to do as much as I can. Can you factor this first though? Did you factor everything? What's a factor on the bottom?
2x plus 3x times
2 parenthesis x plus 3 and x minus 3. What do you see here?
yeah, it's 2x.
Oh, 2x, good. What do you see here?
Cancel x minus 3.
Cancel the factor, right? That means what? There is a hole. If it's a hole, you gotta go find it first. For me, like, I think hole should be changed to first priority. Is any holes? I hear there is holes. Holes coordinate is gonna be what? Can I plug in the 3? 1 over 2 times 3 plus 3. So that's equal to 1 over 54? No. 6 times 6. 36? Okay, so 1 over 36. 3 and 1 over 36 is the whole, or removal of discontinuity. I will find that first. But now I got this new function. Right? This new function that I have a lot of things of. So what are those? Can you tell me about y-intercept? Can you tell me about domain? Oh no, some symmetries. Symmetry in this case, this has no symmetry. Is neither. So there's no symmetry. But it's just because the asymptote shifted. X-intercept. How do you find x-intercept? Huh? 0 and then 1 over 2 times x plus 3. That's not going to happen. There's no x-intercept. Nothing you can solve for because you multiply both sides by 2x, x plus 3. It's going to be 0 equal to 1. There is no x-intercept. Y-intercept. That means plug in x is equal to 0. What am I going to get?
There's nothing.
0 minus 3 over 2, 0, minus 18 times 0. So it's 0, negative 3. There's no y-intercept. Holy shit, there's no y-intercept. Do you know why there's no y-intercept? Because the vertical asymptote is where? X equal to 0 and x equal, so 2x. So 2x equal to 0 and x plus 3 equal to 0. There's the leftover. X equal to 0, x equal to negative 3. So you got no x-intercept and y-intercept because there was a horizontal asymptote and there's a vertical asymptote at 0. Yes. Just minus 3 because you only said x plus 3. It's not x squared minus 9. It's x plus 3, just negative 3. It's not x squared. How about horizontal asymptote? Y equal to 0. Yep. Okay, let's graph it. We're gonna study the behavior in a second. So at 0 it's gonna be here. At 0 here. What else? Yeah. And there's a whole 3 and negative 3, sorry. This is a negative 3. I'm gonna just finish on the video so you guys can go. And you guys can watch it at the end if you need it. It's not even.
It's needed, but
So I'm gonna study how they behave.
I know it's regular. They're plugged in with.
So the new function is gonna be
It's like this, right? And then this point would be at y is 2.9, negative 2 over 9. If you plug in like middle point,
yeah, you can do that.
is there a better way to do it?
No, I mean just you're gonna study the M behavior. That's what I'm gonna do. I'm gonna plug in here. Negative 2.9. And this one is gonna give you 2.9 is gonna be 1 over negative. It's positive. So it's going to be negative. So this one's going to be negative. And if you plug in that is 0.1, negative 0.1 is going to be positive, negative, and positive. So that's equal to negative, so it's going to be like this. And this part is already here, so it's going to be like this. There's a hole there, though.
Yeah.
Yeah, that's good. Robert, you're doing good.
I'm going home, Mr. Yeah.
Why?
I got a dentist appointment.
Robert, if you come the first day, don't skip 2 weeks of school, you would have survived in calculus as well. You know that's true.
Probably, yeah.
Why is there parabola?
Because see, it's gonna go down because they say on this side it's gonna go down. And on the positive side, I'm gonna plug in 0.1 there. So it's gonna be positive on the top, positive, and positive. So it's positive infinity. So this one's gonna go here. So this is the graph. I don't know what I want to teach today. What do I want to teach today? What did you say?
Self-respect pissed me off yesterday.
Me?
Talking about age. I think the first time I was upset.
Talk about what?
Talking about age, making an excuse.
Oh no, I feel old.
Shouldn't like downplay it. Oh,
I'm old.
okay.
I'm twice, almost what, 3 times your age? 43.
40. Middle age.
Middle age. 30 years later, I'll probably be dead. Or I probably died way earlier than that.
Holy.
I only have 29 years to live.
You're gonna be one of those people that live to 100.
Oh, oh no, I'm gonna die like way before that.
But like it runs in the family, right? So you're like, have your parents like turn 8.
No, my dad died at not 70 something. 70, he died at 76, 78. That's still pretty good though. That's still pretty good. There's a lot of people who die a lot, which is sad. My mom's still around.
Yeah, that first lady. Stay in front of her, lift